This is part 6 of section R.7, rational expressions. Now we're going to talk about complex rational expressions. When sums and or differences of rational expressions appear as the numerator and or denominator of a quotient, so sums and or differences of a rational expression. Notice that's what we're seeing here, a difference of two rational expressions. The quotient is called a complex rational expression. So to simplify a complex rational expression means to write it as a rational expression reduced to lowest terms. This is how we're going to simplify. We're going to treat the numerator and denominator of the complex rational expression separately. Performing whatever operations are indicated and simplifying the results. And then we'll follow this by simplifying the resulting rational expression. So what we have is the difference of 2 on top of this other rational expression, x minus 3. So the first thing that has to happen is that subtraction. So we're going to consider those first. This looks a lot like the last example we worked where we had x plus 3 and x minus 3. So we know that the common denominator of these two, since they won't factor any further, will be x plus 2 times x minus 2. So I can go ahead over here and write this little note to myself. The LCM is going to be x plus 1, x minus 2. Okay, so let's write these. We know how we did that before. We started by writing each one just as they are, but factored. Of course, since they won't factor further, all I'm really doing is adding parentheses. And this is all over x minus 3. And then we ask what's missing. And of course, in the first rational expression, what's missing is the x minus 2. And in the second, what's missing is the x plus 1. Now resist the urge to cancel, because the whole point is to have a common denominator, not to cancel and go back to not having a common denominator. Okay. Next step, we're going to FOIL the top numerator here, FOIL the numerator there, and write our result over our common denominator of x plus 1, x minus 2, and of course don't forget this is all over x minus 3. Foiling the first, we get x squared minus 4x plus 4. Then we're going to subtract, and remember everything that comes next has to be subtracted. So if you don't put the bracket, you'll probably get your signs wrong. X squared plus 1x plus 3 plus 4x plus 3. Okay? Now let's distribute that negative so that we have x squared minus 4x plus 4 minus x squared minus 4x minus 3. All over x plus 1, x minus 2, and that is all over x minus 3. Combine like terms in the numerator. Notice that x squared and minus x squared, those cancel. And then we have minus 4x for a total of minus 8x, and 4 minus 3 is 1. And our numerator now, our original numerator, we've completed the subtraction. And it's one fraction now. So to divide, we can think of this, the denominator is a fraction also. You can just put it over 1. And notice that we have a fraction divided by a fraction. Remember the keep it, change it, flip it? That's what we'll do. We'll keep negative 8x plus 1 over x plus 1, x minus 2. We'll change this division to multiplication, and we'll flip 1 over x minus 3. Flip the bottom one, and our final answer then is negative 8x plus 1 over x plus 1, x minus 2, x minus 3. We can't simplify that any further. We can't factor this any further or cancel anything out. Okay. We'll complete example 9 in the next video.